And folks, all right, so we're starting with number one. We've got a car moving at 26 meters per second due north, and we're asked to find the velocity of the car after a certain amount of time if it has two different accelerations. So, this is number one. The number one. So written Y for this one, I would say some things like velocity is a is a vector, and when velocity and acceleration are in same direction, the car speeds up. And then I'd also put something like the opposite is also true. All right? So those would be kind of the ideas in my Y. I might also include, just to complete the thought, the longer, i.e. time, the more velocity change. Because take, for example, this car is moving north. If it accelerates for long enough in the southerly direction, what's the car going to eventually do? It's going to be slowing down the whole time. What's it eventually going to do? Stop and change direction, turn around, and start going the other way. So, all right, so let's do part A. The equation I'm going to use for this, I'm going to go to my equation sheet, and I'm looking at, hey, what's the new velocity, because it started at this velocity and it accelerated for a certain amount of time. I'm going to use this one right here, which says, hey, you end up at this velocity because you started at this velocity and you accelerated for a certain amount of time. Seems to fit the situation. Everything you need, is, as always, is on the Google Classroom. I think it's on the, if you limit your stream to just Unit 4 and you look at the first posting, I think it's attached to there. If not the first, it's the second. All right, so that's going to be my equation. So I'm going to use V final equals V initial plus 2A delta T. V final is what I'm looking for. V initial. Which direction do you guys want to call positive, north or south? North? Okay. So, positive 26 meters per second plus, where did that 2 come from? There's no 2. Plus, there's no 2. I was not paying attention to what my hand is doing. 1.6, and it's north, so it's positive, times 7 seconds. And then part B, exact same formula. Except this time, my acceleration is south. So it'd be negative 1.4 meters per second squared times 7 seconds. if I get a positive velocity final, which direction is it moving? North. And if I get a negative, it's moving south. So, okay, that's it for that one. All right, so on to number 3 here. Skier starts from rest. Oh, that means initial velocity is 0. It accelerates down the slope at 1.3 meters per second squared. How much time is required to reach the speed of 8.4 meters per second? Ah, this is like identical to number 1, except easier. Cool. Alrighty. Grab a pen. And let's see. C number 1. Since Cochrane's lazy. Alright. And then I'm going to use V final equals V initial plus A delta T. Does everyone understand that equation now? Yeah? Okay, so we have a V final now. It's 8.4 meters per second equals 0 plus 1.3 meters per second squared delta T. Solve for delta T. Yay! Alright, so 13. We have an airplane. It begins to slow down as it moves along the runway. Has this mass and has this net braking force. What is the airplane's acceleration? So I'm going to need to do a force diagram of the airplane here. And let's see. So we really don't need to write anything, but here's my wonderfully drawn airplane. I'm going to have its weight down, normal force up. Do those two contribute to the airplane's acceleration?
Nope.
Nope. Just to remind myself, I'm going to have it moving in that direction, but a force against it. Therefore, the acceleration is going to be in the same direction as my net force, and my net force is in the same direction as that single force there. So, going to my equation sheet here, I'm going to use sum of the forces equals ma, Newton's second law there. Only one force is influencing my acceleration. Which way do you guys want to call positive and negative? Zach, how about you? Which way? To the right? Okay. Now, Zach, why'd you pick to the right?
Because that's the way.
Okay. Okay. I just asked because that's going to make everything that we're going to deal with mathematically here negative, which is fine. I just find that 90% of students screw up on their negative signs. But let's do it. So to the right positive, that means I have negative F equals M times a negative A. And I want to know, what do I want to know? The acceleration. So I'm going to get the acceleration by itself. F over M equals A. Oh, they tell me F. Let's see, 4.5 times 10 to the 5th newtons. Please do remember how to put scientific notation in your calculator, otherwise you won't get the right answer. and 3.5 times 10 to the 5th kilograms. Oh, that's nice. That's 3.5. 3.45.
Then you don't have to raise.
Yeah, I could mathematically, I could get rid of those, couldn't I? Yeah, you can see that. That's a good help. And then you get whatever acceleration is in meters per second squared. Yay! Another one bites. 8 was not one selected. Nope. All right, we have 15 here. You've got the crew member standing on the bow of a ship. I like this problem because it's an elevator problem without the elevator. One thing to always keep in mind, what force does a scale measure? No, not the weight. Not the gravity, which by another name would be the weight. Normal force. Normal force. You gotta keep repeating that to yourself so it gets so you don't have to use Drew. Alright. So, go ahead and read this. In calm waters, the normal force on the person is 755 newtons. During the storm, the crew member observes a normal force, maximum normal force of 930 newtons, and a minimum normal force of 560 newtons. And then they want me to find the acceleration upwards and the acceleration downwards. So, force diagrams again. We'll be boring and do black. So, there's our crew member. We'll draw him 3 times. So this will be calm, this will be max, and this will be mid. All the times has the same weight on him. All the time has a normal force. What would happen if he didn't have a normal force? He'd be experiencing weightlessness. He'd be accelerating down at free fall acceleration. So, the difference here is which direction is he accelerating at when it's calm? Which direction is he accelerating when the seas are calm? Guys, show me who's working on this problem so I don't stare in the wrong places. Okay. Okay, good, just enough. So how much is he accelerating? Which direction is he accelerating when the seas are calm? He's not. Good. Maximum acceleration, when that normal force is at its peak, which way is he accelerating? Up. Which way is he accelerating when it's at its minimum? Down. And I might even write in here, just so I really understand, scales measure force normal. Nice thing is, once I figure out it's a force problem, I really only have one equation. Right? So let's take calm first. Calm. I have force. Which way do you guys want to call positive? Up. Okay. So I have force normal minus F sub g equals his mass times the acceleration, which would be 0. So force normal, yeah. Oh, thank you. What am I going to do without you? I don't know. Right? So, all I can figure out is mass, right? Because they tell me what the normal force reading is at that point. So I can do a little bit of math. Let's see, what is it? It's 755. What is, oh, they want to know the acceleration. That might be helpful. All right, let's switch colors so we can tell apart. And now do max. I'm waiting. Not me or some? Oh, okay, sorry about that. Use the same formula. Force normal minus the weight equals m, and it's a positive A. Yeah.
The complex, the 755, it didn't work out when I did, like, my home water reading divided by 9.8.
Could be how do you know it didn't work out? Well, this is a good time to look at what they actually asked me to calculate. And they asked me for the acceleration when it's upwards and the acceleration when it's downwards. So I'm not surprised that the mass didn't answer either of those questions. I'm glad it didn't, actually.
Okay.
We're gonna end up needing the mass. You'll see. So let's see, what do I know? Oh, I know the normal force, right? They tell me that when it's at a maximum. Let's see, what do they say? It's the max, 930. 930 newtons minus, I know the weight, 755 newtons. I know the mass, it's whatever I figured out up above, and I'm left with A. And I want to find A. Cool. Let's do the minimum and do it over here just so they're all together. Same equation again. Except this time my acceleration is negative. So I end up with 900, not 930, but what do they tell me? 560 minus 755 equals m, whatever it is, times negative A. Glad that A is negative because 560 minus 755, that's a negative number, isn't it?
Yep.
So if the A wasn't negative, I'd have to have negative mass, and antimatter would not go well here on the ship. So luckily, I get a positive acceleration again. You see where you use the mass there?
Yeah.
Yeah. If I finish the ones that were selected by the class, yes, I'd be glad to.
I substitute my 5 with 2. I'm the one that suggested 5.
You weren't. All right. 17. A fly walks straight up a window pane. Let's see. Oh, they're playing around with some units here, aren't they? What's the mass of the fly given in? Grams, what do we normally use? Kilograms. And the window pane, centimeters per second rather than meters per second. And then the answer in milliwatts. So I gotta watch my units here. So, so 17, I would define power then I'm going to jump to my equation sheet and see that I have this equation for power, this long one. I'm going to use the two outer sides. Power equals force times velocity. Now I'm going to remember, if I have my little fly here, his weight is going to be downwards and his velocity is going to be upwards. So the power is going to be his weight times his velocity. His weight will be mg and this will be v. I would suggest changing his mass in grams to kilograms. 1.2 times 10 to the negative third kilograms. 9.81 newtons per kilogram. And I would do the velocity into meters per second. So 2.7, 0.027 meters per second. That'll give you a power in watts. And well, milli is negative third, like millimeters. What I would do though is change my units to watts here in the problem. Rather than using milliwatts, I change it to watts. That would be my suggestion. Are we good on this one? Didn't work. Let me try it. All right, we're going to do number 8.
Yeah. Thank you.
Just part C and D?
Yeah.
Oh, sure. Yeah, that's a piece of cake. So, I'm assuming then that, okay, so we know the position. All right. Tell you what, I'll even skip the Y on this. Because if you don't have the Y, you're messed up on the test, so that's okay. So we'll start with part C. I'm just going to go back here to my equation sheet and pull out my main equation here, my main kinematics one, and write it down. And now I know everything in there except for A. So I know, because they tell me, I figured out in part B that they passed at, in my case, 115 meters. That's where they met up at. So that's my D, 115 meters. My D naught, well, it started at 0, so that's going to be 0. My V initial, it also started at 0, so that's going to be 0. Hey, that's a piece of cake. 1/2 A, and they tell me my time. For me, it's 10 seconds. And so I get an acceleration.
Wait, so then
From doing part B.
do you divide by 1/2?
Do I divide what by 1/2? No, if I want to get the 1/2 to the other side, I would multiply both sides by the reciprocal of 1/2, which would be 2.
Is that the same thing as dividing by 1/2? Like when you said-
Oh, sure, yeah. I guess it is. Yeah, they said skip A and B, they're easy, we got it. So I did.
It's just weird because you couldn't actually see what the hell could be.
Yeah, well, they said they already had A and B.
Oh, I don't know. You guys have.
Oh, sorry. Most common mistake will be to forget to square 10 there. And what's the speed of motorcycle 2 when it passes motorcycle 1? I'm going to use V final equals V initial plus A delta T. I could use either of these velocity equations over here because I know so much. I'm just picking the one that has easier math, to be honest. V final is what I'm looking for. V initial was 0. So whatever my answer to C is, times 10 seconds. And that's that problem. Alright, well, we'll get at least a little bit done on 12 here, which is the hot air balloon going up, and you drop the camera, and what is the time it takes to reach the ground? So, factors I would put in here, things like balloon and camera start upwards. Camera is in free fall.
Good morning, Melrose.
All right.
Today is Monday, March 13th, and it is a day one. Please stand for pledge allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Please be seated. The National Honor Society is started at the intermission program. Sharing completed at NHS, gmail.com, NHS members. Please edit your wish on this conversation. Make sure to listen to prompts in the guidelines on the top left. From now to the end. What's today's birth party? Boys Spring Track, there will be a free meeting for anyone interested in Spring Track Tuesday, March 14th. The Students of the Cells, the program center for recreation, natural history, and conservation of those themselves. Through this event, on up the Cells region, the guided by Open House Special Education is tracking to take place this Thursday. Please see the story for
Position where it starts. DO is the position that it starts at.
In the administrative conference room, there will be a meeting with a representative from Brandeis University about the British College program. This meeting is open to students in grades 9, 10, and 11. Thank you.
What screws up a lot of people is they worry about, oh, wait a minute, it's going up and it's coming down. But we don't care about that. We look at the beginning, we look at the end. Because it's displacement, not distance. All right, folks, I got to stop there so I can save stuff.